Hi, so this video is just to continue on what we were doing in the last video, and I believe we solved 9a. So I'm going to do B, C, and F in this video, and hopefully you can try D and E on your own. So B tells me, so I look at the second term, I know my x has to be bigger than 0. So the first term tells me that my x plus 2 has to be bigger than 0. So I have to check whenever my x is inside the ln or the log function, I want to make sure that it's always bigger than 0. So that means that x has to be bigger than -2. And if it's bigger than 0, it's already going to be bigger than -2. So we don't have to worry about that. And this tells me that 2x minus 1 has to be bigger than 0. So 2x has to be bigger than 1. And x has to be bigger than 1 by 2. And we don't have to change the direction of the inequality because 2 is positive. So x is bigger than 1/2. And if x is bigger than 1/2, it's automatically bigger than 0. So now that we know that x has to be bigger than 1/2, we can start solving. And we don't like having these numbers in the front because they prevent us from using the rules of logarithms. So we just put it on as an exponent, and the left hand side you can see simplifies to x plus 2 squared divided by x, because minus ln x just means that we can divide whatever the terms we have inside the ln function, and on the right hand side we have ln 2x minus 1. So we have x plus 2 squared divided by x is equal to 2x minus 1. If I multiply both sides by x, I get x plus 2. Then I can actually finish the square. So this is going to be the first term squared, plus you multiply these two. 2 times x is 2x, and then you multiply by 2 again. So that's 4x plus 2 squared is 4. And I have 2x squared minus x when I multiply by x on this side, or when I multiply by x on both sides. And these cancel out. So now I have 2x squared minus x squared. So if I subtract x squared on both sides, I have x squared. I have 4x. If I subtract 4x on both sides, I have minus 5x. So minus x squared minus x squared minus 4x minus 4 minus 4x and minus 4. So if I do this side is going to simplify to 0. And this side is going to be, so whenever we talk about taking something to the other side, this is actually what we are doing in the background. So this side simplifies to 0, and on that side we have x squared minus x minus 4x is minus 5x minus 4, because this is just plus 0. So now we have to solve this, and let's use the quadratic formula. X is equal to 5 plus or minus the square root of 25, and I'm doing this very quickly here, minus 4 times, so this is going to be plus 16 over 2. So that is 5 plus or minus, and remember, it cannot be negative. So square root of 36, so that is 41. So if this was 36, it would still be 6. It would be bigger than 5. So we don't want to take the negative here. So it's going to be 5 plus square root of 41 by 2 is your answer. And if you actually simplify everything out and you put it in your calculator, you will see why one answer is not valid. Because it's going to be negative, and we want our answer to be bigger than 0.5. So x plus square root of 41 divided by 2 is 5.70 to two significant figures. Now, I think I said C and F. So let's do C. So this part tells me that 2x plus 3 has to be bigger than 0. So 2x has to be bigger than -3, and x has to be bigger than -3 by 2, which is -1.5. And this part tells me that x plus 1 is bigger than 0, so x bigger than -1. So if x is greater than -1, it's automatically greater than -1.5. So we don't have to worry about the first inequality. So this is all that we want, x bigger than -1. So let's solve it. I don't like numbers in front. So from this, we can deduce that x plus 1 squared is going to be equal to 2x plus 3. So you have x squared plus 2x. X times 1 is 1x, times 2 is 2x, plus 1 is 2x plus 3. So if you subtract 2x on both sides, these get cancelled out. And x squared is going to be equal to 3 minus 1 is 2. So x is going to be positive square root of 2. Negative square root of 2, if you calculate it, it's less than negative 1. So square root of 2 is 1.41, two significant figures. And finally, let's do f. So this, again, we know how to deal with this. If I have a 1, that's just ln e. Ln base e of e is going to give me 1. So I have ln 2 plus x squared, and on the right hand side I have ln e plus ln x squared. So this, I'm putting it as an exponent. And I can combine this. This is just ex squared. And I can now equate this and this. Or you can think of it as, keeping those as the exponents and having your base as e. So e to this and e to this gives me ex squared is equal to 2 plus x squared. Now I want my x squared term to be together. Ex squared minus x squared is equal to 2. E minus 1 x squared is going to be 2. X squared is equal to 2 over e minus 1. And let's check. Because this tells me that x is bigger than 0. And we have x squared bigger than negative 2. Which is automatically included in the case that, well, x squared is always going to be positive. So I don't have to worry about it being bigger than negative 2. But I want x bigger than 0. So I want to take the positive square root. So when I take the square root of both sides, I just want my answer to be positive. So 2 divided by e minus 1 to the power 0.5 gives me 1.08 to 3 significant figures. So I leave d and e for you to try on your own. So express y in terms of x for each of these equations. So we have 2 ln y plus 1 minus ln y is equal to ln x plus y. And we just want to try to isolate. So on the left-hand side, I can write as ln y plus 1 squared minus ln y is equal to ln x plus y. And I can simplify further. I can write it as y plus 1 squared divided by y. Using the laws of logarithms, I have ln x plus y. And now, because the bases are same, base e, I can equate the arguments. Y plus 1 squared over y is going to be equal to x plus y. And when I multiply by y on both sides, is it a good idea to multiply by y? Let me think. Because we want to write y in terms of x, I believe. Yes. So let's multiply by y. Anyways, so multiplying by y on both sides. So the y in the denominator will cancel out. And I have y squared plus, so if I expand the brackets out, I get 2y plus 1 equal to xy plus y squared. And y squared, if you subtract y squared from both sides, they cancel out. So I have 2y minus xy is negative 1. So if I subtract xy on both sides and subtract 1 on both sides, I get this. And now I can factor out a y is equal to 1. And y in terms of x is going to be 2 minus x. I seem to have missed a negative sign somewhere. Oh, sorry. Because this is negative 1. So I have negative 2 over x, right? Because 2y minus xy we said was negative 1. So 2 minus x times y is negative 1 because I factored out the y. And y is negative 1 over 2 minus x. Or actually what you could do is, because I have a negative here, the negative, I can associate it with the numerator and I can multiply by negative 1 on both the numerator and the denominator. And this does not change because these will just cancel out, right? So when I do that, the numerator becomes positive 1 and the denominator becomes x minus 2. So that is the answer in the textbook, but the answer that I initially gave is also equivalent. 10b is ln y plus 2 minus ln y is 1 plus 2 ln x. ln y plus 2 over y is equal to ln e plus ln x squared. And this just simplifies to ex squared. And now we can equate the arguments. Ex squared is going to be y plus 2 divided by y. And y multiplying by y on both sides, times y, and these cancel out. Ex squared is equal to y plus 2. Now if I subtract y on both sides, I get this. And I can now factor out the y. So therefore, y is equal to 2 over ex squared minus 1. So that is your answer. And now we'll do A and D. So remember, e to the power x is always bigger than 0. So when we solve the quadratic equation, and we are going to be solving quadratic equations here, we don't want to have negative values for as our answers for e to the power x. So that is something to keep in mind. So 11a, and I'm only solving 11a and d, says e to the power 2x plus e to the power plus 2e to the power x minus 15 is equal to 0. So if I say that, hey, if u is e to the power x, then e to the power, well, the first term is just e to the power x squared plus 2e to the power x minus 15 equals to 0. So I have u squared plus 2u minus 15 is equal to 0. Now, can I factor this? Let me think. 5 and 3. So plus 5 minus 3 is going to give me 0. U squared minus 3u plus 5u, that's 2u minus 15. So u is equal to 3, or u is equal to negative 5. But if I set this to be 0, I get u negative 5. If I set this to be 0, I get u 3, right? So if you've been confused on how I've been getting these, it's the case that either this part is 0 or this part is 0. So u minus 3 equal to 0 and u equal to 3, like this, or u plus 5 equal to 0 and u equal to negative 5. So we said that u is e to the power x. So e to the power x is 3, or e to the power is negative 5. But remember, we just said that e to the power x is bigger than 0. So it cannot be negative 5. So now we solve for x by taking the log on both sides. So x is going to be ln 3. So that is your answer for 11a. And for 11d, you have e to the power x minus 21 e to the power minus x is equal to 4. Well, you can rewrite this as e to the power x minus 21 over e to the power x is equal to 4, because that is what e to the power negative x means. And now if I multiply by e to the power x on both sides, then I get e to the power x plus x is 2x minus 21 is equal to 4 e to the power x. And now again, if I say e to the power x is equal to u, then I have u squared minus 4u minus 21 is equal to 0. And I believe I should be able to factor this again. It's minus 7 plus 3 equal to 0. So now, setting this to be 0, I get u is equal to 7, and setting this to be 0, I get u is equal to negative 3. However, e to the power x, so u was e to the power x, and e to the power x cannot be negative 3. So I only solve for e to the power x is equal to 7, so therefore x is ln 7. So that is how you solve. And these are very similar to the questions that we have been doing. So I leave B and C for you. To solve this, giving your answer correct to 3 significant figures. So I have 2 ln 3 minus e to the power 2x is equal to 1. And I can say ln 3 minus e to the power 2x is equal to squared is equal to 1. Well, this is just my natural log. I have a base e. So if I raise e to the power 1, I get 3 minus e to the power 2x squared. And I can so now, well, I can say that e to the power 2x is equal to u, right? Which is e to the power x squared is equal to u. So e to the power 2x is equal to u. So I have u squared u squared, right? Because e to the power 2x is u in this case. And now I can expand this. I can say this is 9 minus 6u plus u squared. And you can just do it like this. 3 minus u, so 3 times 3 is 9, minus 3u gives you minus 6u plus u squared is equal to e. So I have u squared minus 6u plus 9 minus e equal to 0. And I'm solving for u here. And u has to be positive. So if I use the quadratic formula, u is equal to 6 plus or minus the square root of 36, minus 6 squared is 36, minus 4 times 1 times 9 minus e, all over 2. So if I solve this, I get 36 minus 4 times 1 times 9 minus e gives me 10.8731, and if I take the square root is 3.29. So I have 6 plus minus 3.297442541. That is what I have in my numerator, divided by 2. So u, as you can see, is positive. So u is equal to, now if I take 6 plus the answer, and 6 plus whatever we have here, and divided by 2, I get u is equal to 4.6487, and we just want to write it in terms of 3 significant figures at the end. And u, if I take the minus form, is u minus the answer divided by 2 is 1.35127873. And remember, this is e to the power 2x. So e to the power 2x, e to the power x is going to be the square root, the positive square root of these answers. Because this is e to the power x to the power 2. So if I take the positive square root, then I get 2.156, and when I take the natural log to solve for x, I get 0.768. And from this side, e to the power x, I get e to the power 2x is 1.35127873. So if I take the positive square root of both, sides, I get 1.162445151. And when I take the natural log of both sides, I get 0.15052. So 0.151 to 3 significant figures. So now we want to substitute back, because we have a restriction. Let's not forget that. And our restriction is that 3 minus e to the power 2x must be bigger than 0. So let's substitute back our x's. So if my u, which is e to the power 2x, don't forget. So if e to the power 2x is 4, then 3 minus 4, that is going to be less than 0. It's just going to be negative. So this answer is not possible. So only this answer is the correct answer. So now we have question 13, which is solving the simultaneous equations. So 13a gives 2 ln x plus ln y. So always remember to check your domain when you do these questions. 1 plus ln 5. So here it tells me x is bigger than 0, y is bigger than 0. So I'll immediately write it down. And my second equation, so I want x bigger than 0, y bigger than 0. I'll reject all negative answers. And I have ln 10x minus ln y is equal to 2 plus ln 2. Now, if you think about it, we can just add these two equations. Because I have a plus ln y and I have a minus ln y. So when I add them together, these are going to cancel out, it gives 0. So I have 2 ln x plus ln 10x is equal to 1 plus 2 is 3 plus ln 10, right? How did I get ln 10? Well, ln 5 plus ln 2, we can simplify by writing it as ln 5 times 2, and that is ln 10. And now I can write it as ln x squared. I don't want numbers in front of my log, so ln x squared plus ln 10x can be written as ln 10 plus ln x, right? And that is 3 plus ln 10. And ln 10 cancel out. We can subtract ln 10 away from both sides. So I have ln x cubed, because x squared and x, so they combine together. Ln x cubed is equal to 3. So 3 is just ln e to the power 3. And therefore, x cubed is going to be e to the power 3. X is going to be e. And e is greater than 0. And when I say x is equal to e, then now I can just substitute back. Let me just use my first equation. 2 ln e plus ln y should be equal to 1 plus ln 5. So ln e is just 1, so this is just 2. So ln y is just ln 5, and if I subtract 2 on both sides, I'm going to get minus 1. And minus 1 is just, 1 can just be written as ln e. So ln y is equal to ln 5 divided by e. And therefore y is going to be equal to 5 over e, or 5 over x. So x is equal to e, y is equal to 5 over e. That is both greater than 0. So that is how you solve 13a. And let's look at 13b. I have e to the power 3x plus 4y equal to 2e to the power 2x minus y. And I have e to the power 2x plus y equal to 8e to the power x plus 6y. So this is equation 1, and this is equation 2. Now if I use equation 1, let's see. So I think one way to approach this would be to write all your x's and y's, x's on one side and y's on one side. So let's use equation 1. I know that I can write it as e to the power 3x times e to the power 4y, because if we have the same base, when we multiply them together, we are allowed to add the exponents together. And here I have 2e to the power 2x minus y, which I can write as 2 e to the power 2x, e to the power 2x over e to the power y. And now, I can multiply by e to the power y on both sides, if that is, well, let me divide by e to the power 2x on both sides. And the reason I'm dividing by e to the power x on both sides is I can cancel this, and I don't have to worry, because e to the power 2x can never be 0. So I am allowed to cancel them out on both sides. So this side, I have e to the power 3x minus 2x, that is just x, times e to the power 4y is 2 over e to the power y. And if I simplify this further, I have e to the power x is equal to e to the power 2 divided by e to the power 5y, right? Because I'm dividing by 4y on both sides. And the 4y's here cancel out. These add together to give me e to the power 5y. So now I can take the logarithm, right? I can take the natural logarithm of both sides, and I get x is equal to ln 2 minus ln e to the power 5y, right? Because we are allowed to use the laws of logarithms. So I think we get this expression. And finally, I can say that x is ln 2 minus 5y. So that is what we get from our first equation. So let's use our second equation. We have e to the power 2x plus y is equal to 8e to the power x plus 6y. So I know that this is e to the power 2x times e to the power y, and on the right hand side we have e to the power x times e to the power 6y. And now I can divide by e to the power x on both sides. So these cancel out and I get e to the power 2x minus x. That is going to give me e to the power x times e to the power y is equal to 8e to the power 6y. And if I divide by e to the power y on both sides, then these cancel out and I get e to the power 5y. So I have 8e to the power 5y. And you can take this a bit slow, or you can rewind to sort of digest the steps that I did in quick succession. So now I can take the natural log of both sides and I get x is equal to ln 8 plus 5y. So this, I think, is what it simplifies to. Now from equation 1, and equation 2 tells me that, hey, your x is equal to ln 8 plus 5y. And if you look at these two equations, I can add them together. And when I add them, I get 2x is equal to ln 16. Ln 2 plus ln 8 gives me ln 2 times 8, that is ln 16. And this minus 5y plus y is going to give me 0. And therefore, x is equal to ln 16 divided by 2. And we can simplify this further because, again, 16 is just 2 to the power 4. So when I bring this 4 to the front, I have 4 divided by 2, that is just 2 ln 2. That is your x. And my y is going to be 2 ln 2 equal to ln 8 is 3 ln 2, right? Plus 5y. Why is it 3 ln 2? Well, because 8 is to the power 3. And now I know that 5y is equal to minus ln 2. So therefore, y has to be negative 1 over 5 ln 2. So that is your answer. And finally, we have question 14, which is solve this equation. So I have ln 2x plus 1 less than or equal to ln x plus 4. So if the ln of this is smaller than the ln of this, then the arguments follow the same pattern. The argument must, because remember, a logarithmic function is an increasing function if the base is bigger than 1. And e is bigger than 1. So we have 2x plus 1 is less than or equal to x plus 4. And this is very easy. If you subtract x from both sides, you get x plus 1 less than or equal to x plus 4. Sorry, just 4. And then you go x is less than or equal to 3. However, that is not the end. Because we also have to remember that they carry their own restrictions. So this tells me that x plus 4 is bigger than 0. So x is bigger than negative 4. And this tells me that 2x plus 1 is bigger than 0, so x must be bigger than negative 1 by 2. So negative 1 by 2 is going to be my lower bound. Negative 1 by 2 less than x less than or equal to 3. So always start from checking these because they tell you very important information about restriction on x. So why don't I take negative 4 where there are numbers between negative 4 and negative 1/2 in between that don't satisfy, because we want our x to be bigger than negative 1 by 2. So these numbers are not bigger, so therefore we cannot choose them. So that is your answer to 14. And that is about it. So we are almost done with the chapter. We have one more topic about linearization, and then we will be able to close the first chapter.